In an era of AI-driven automation and hyper-advanced robotics, the world's most critical mining operations still rely on 50-year-old giants. These massive walking drag lines defy modern logic, outperforming the newest hydraulic excavators through pure physics and sheer scale. Today, we're dismantling the engineering secrets behind why these vintage titans remain the irreplaceable kings of the open-pit mine. Welcome back to Motor Vibe Talk. Just look at this thing for a second. It has a boom stretching over 300 feet into the air. That's nearly a football field standing on its end. Its bucket? It can swallow two full-sized pickup trucks whole and still have room for dessert. It weighs as much as 15,000 family cars. And here's the kicker. Most of these monsters were built back when bell-bottoms were in style and Nixon was in the White House. In an age where your smartphone becomes a paperweight in 2 years, these drag lines have been running 24/7 for 5 decades. They aren't museum pieces sitting around rusting in a field, though you'll find a few of those. No, these are the active, beating hearts of global coal production, from the Bowen Basin in Australia all the way to the Powder River Basin in Wyoming. So, why? Why haven't they been replaced by sleeker, high-tech modern machines? The answer isn't just they don't make them like they used to. It's about physics, cold, hard economics, and a 1913 invention that simply refuses to die. Let's dive in. Part 1. The scale of the impossible. First, we really need to wrap our heads around what we're dealing with here. A walking dragline isn't just big, it's in a category of its own. We're talking about machines with booms that can exceed 300 feet. The base they sit on, which miners call the tub, can be over 100 feet in diameter. Picture a massive dinner plate for a giant, and you're getting close. To give you some perspective, the largest walking drag lines can weigh over 13,000 tons. The infamous Big Muskie, the largest ever built, tipped the scales at over 14,000 tons. And here's the kicker. Most of these monsters were built back when bell-bottoms were in style, and Nixon was in the White House. Finding the right machine for this scale is crucial, and that's where Mastery comes in. Mastery offers expert advice and access to the largest inventory of heavy equipment in mining, including vintage giants. Mastery understands the unique needs of scale and efficiency, ensuring you get the right equipment to get the job done. Now, why on earth would anyone build something this absurdly large? It all comes down to the dirty business of making money. In open-cut mining, the coal is buried under massive layers of dirt and rock called overburden. Before you can even touch the coal, you've got to get that mountain of rock out of the way, and you have to do it as cheaply as humanly possible. Why? Because moving dirt doesn't make you a dime, selling coal does. A dragline is the ultimate solution. It stands on the edge of the pit and casts its bucket out hundreds of feet like the world's heaviest fishing line. It drops the bucket, drags it back through the rock, and swings 180 degrees to dump the waste onto a pile on the other side. In one single pass, it can move over 100 tons of earth. Modern hydraulic excavators might look flashy and precise, but honestly, they're toys compared to this. To match the volume of just one dragline, you'd need a fleet of dozens of haul trucks and excavators, burning through mountains of diesel and requiring a small army of employees. The dragline does it with just a handful of operators and a direct line to the electrical grid. Part 2. The Walking Paradox. Now here is where it truly gets weird. How do you move something that weighs 13 million pounds? You can't put wheels on it. The pressure would be so immense that it would sink into the earth like a stone in a pond. You can't even use traditional tracks because the soft, unstable ground of a mine would just rip them apart. So, it walks. Back in 1913, an engineer named Oscar Martinson solved this problem with a mechanism so elegant and so tough that we still use it today. Here's the mechanical magic trick. On each side of the machine, there's a massive steel shoe or foot. Imagine a giant lopsided crank. As it rotates, it does this methodical four-step waddle. Lift the shoe, the eccentric cam lifts the massive foot off the ground. Step forward, the mechanism pushes that shoe forward a few feet. Lower the shoe, now the machine is standing on its feet instead of its belly. And the big step. The cam lifts the entire 13 million-pound machine, uses the shoes as a base, and pulls the massive tub forward. This walking cycle allows the dragline to step across the mine at a blistering speed of about 1/6 of a mile per hour. Okay, it's slow, but it's unstoppable. This is why 50-year-old draglines win. Modern machines rely on rubber tires that cost a fortune or complex tracks that need constant maintenance. But a steel walking shoe, it's nearly indestructible. It solves the problem of ground pressure that would crush literally any other vehicle on Earth.
Part 3. Vintage Electrical Superiority. Let's talk about what actually makes that massive arm swing. Inside the house of a dragline, you won't find the complex, finicky hydraulics of a modern excavator. Instead, you'll find massive electric motors, specifically DC motors, that date back to the 60s and 70s. Why stick with DC? Because DC motors are the muscle cars of the electrical world. They provide instantaneous torque. When that operator pushes the lever, the motor delivers maximum grunt from the very first second. That's exactly what you need to sling a 100-ton bucket through the air. Modern AC motors are getting better, but for a long time, they couldn't match the brute force of these vintage DC workhorses. Today, companies like Caterpillar offer high-tech upgrades to the electronics, but the old iron, the actual motors and generators, was built to last a century. This brings up the ship of Theseus paradox. These draglines are technically 50 years old, but are they really? Over 5 decades, almost every internal part might have been replaced. The bearings are new, the gears are swapped, the controls are digital. But that steel skeleton, the boom, the house, the tub, that stays. And that steel is thick. It wasn't built with planned obsolescence in mind. It was built back when engineers over-engineered everything. Compare that to a 2026 machine packed with software locks and proprietary parts designed to break after the warranty is up. Miners look at that and say, "I'll keep the old girl, thanks." Part 4. The economics of moving mountains. Here's the bottom line. Why do draglines still reign supreme? It's the cost per ton. According to the data, draglines are the absolute cheapest way to move dirt in the history of surface mining. They consume less power and emit fewer greenhouse gases per ton than any fleet of diesel trucks could ever dream of. Think about it. A truck fleet needs diesel fuel, tires that cost $50,000 each, and constant engine rebuilds. A dragline? It's electric. It plugs into the grid. No tires, no transmissions, no diesel smoke. And then there's the sticker shock. To build a brand new dragline of this scale today, you're looking at upwards of $100 million, and that's if you could even find a company willing to build one. Most manufacturers have moved on to smaller equipment that's easier to sell. So, a mining company looks at a dragline that was fully paid off back in 1985. It's been maintained perfectly. It has a 300-foot boom and moves 100 tons a swing. Why on earth would they replace it? It's not just a machine. It's a financial asset that basically prints money.
Part 5. The Unshakable Throne. So, is anyone actually trying to dethrone these giants? Well, surprisingly, they're trying to turn them into cyborgs. One of the biggest trends in mining right now is retrofitting these 50-year-old steel skeletons with LiDAR, 3D cameras, and AI sensors. They're using AI to analyze swing cycles and optimize the bucket path to save milliseconds. That sounds like overkill, but those milliseconds add up to millions of dollars by the end of the year. Companies like Komatsu and CAT are even developing remote operation systems so an operator can run the machine from a safe, air-conditioned office miles away. But replace the iron? Not a chance. We've basically hit the engineering limits of what materials can do. Steel is still steel. Physics is still physics. You can't really build a significantly larger dragline because the forces would just tear the metal apart. The walking mechanism, perfected over 100 years ago, is still the best way to move this much weight over soft dirt. The 20th century dragline remains the most efficient tool ever built for the 21st century's massive resource demands. So, the next time you drive past a coal mine or see a photo of one of these beasts, just remember, you're not looking at a relic. You're looking at the ultimate expression of mechanical efficiency. While the rest of the world chases the shiny and the new, the kings of the mine are sitting on their steel tubs, taking slow, methodical steps and moving mountains 100-ton bite at a time. What do you think? Will AI finally push these dinosaurs into extinction, or will they still be walking 50 years from now? Let me know in the comments. If you enjoyed this deep dive into these mechanical giants, smash that like button, subscribe to Motor Vibe Talk, and hit the bell so you don't miss our next look at the big iron. Thanks for watching, and we'll see you in the next one.